Afternoon, ladies and gentlemen. This is day 2 of week 2. So this is numbers 6 through 10. Okay. So let's get started. All right. It's 4/19, Wednesday, April 1st. All right, which means it's April Fool's Day. And if you don't remember from class, shame on you. It is also my birthday today. Okay. Turn 29 years of age. I'm just kidding. That is a lie. I'm 33. But regardless, today is my birthday. So anyway, for those of you that do watch my videos and feel like reaching out and wishing me happy birthday, I would appreciate that. If you don't, that's okay. All right. So which situation could be modeled as a linear equation? All right. Well, the value of a car decreases by 10% every year is option 1. The number of fish in a lake doubles every 5 years is option 2. 2 liters of water evaporate from a pool every day is option 3. And the amount of caffeine in a person's body decreases by 1/3 every 2 hours. Okay, so we have to decide which one of these is not modeled as or cannot be modeled as a linear equation. All right, and so like always, I'm going to do the first 3 that are not, and at the end, I will show you why that is the answer. Okay, so let's take a look at number 1. Okay, what number 1 is saying, okay, so the value of a car decreases by 10% each year. So let's just say the value of your car is $8,000. Okay, and so it decreases by 8,000 times 0.1, right? It decreases by 10% each year. So 8,000 times 8,000 times 0.1 or 10% is 800. So 8,000 minus 800 is 7,200. And then the following year, it's going to go down by that much. So it's going to be 7,200 times 0.1, or 10%, which means it's going to go down by 720. So 7,200 minus 720. So let's take a look for a second. So our first year, this is year 1, all right, our first term is 8,000. Our second year, our car is worth this much. Our third year, our car is worth this much. All right? And to find what our fourth what our car is worth our fourth year, again, we're going to take 6,480, multiply it by 10%, and then subtract that amount. So 6,480 minus 648. You get 5,832. Okay, and so when we're talking about linear equations, we're talking about a constant rate of change. Okay, and what's happening here is we're actually taking our first term or our first amount and multiplying it by 0.1 each time. So if you guys recall, that kind of function isn't linear. This one is exponential, right? Because in order to find the value of our car, you're taking that value, like we did over here, you're multiplying it by 10% or 0.1, and then subtracting that amount. Right? So your car is decreasing by 10% of its value each year, which means your equation would look something like this. So you'd have your initial amount, right? You guys remember? Very something similar to that, okay? Anyway, so This one's out. That's an exponential, right? We're multiplying by 10% each time. This one, the number of fish in the lakes doubles every 5 years. Okay, so let's start it out with 2 fish. Well, it doubled after 5 years, which means it went to 4. Okay, I'm just making this up. Maybe it's a very small lake. All right, and then what happened that following 5 years? All right, so 10 years later, it's multiplied by 2, right? Doubles. And so now 10 years later, you have 8 fish in the lake. Okay, so on and so forth. So what's happening here is you're starting with some initial amount, and it's doubling each year. Okay, so you're starting with some initial amount, and it's doubling. Woo! Excuse me. All right, so again, you got some equation that looks like this. Because it's doubling each year, that means this is also some sort of exponential. Okay, it's doubling each year. It's being multiplied by 2 each time. Well, let's take a look at number 4 here. All right, if you've already chosen number 3 is correct. Okay, and I'll explain why number 4 is not. So the amount of caffeine in a person's body decreases by 1/3 every 2 hours. So let's say that first hour you have, I don't know how much caffeine you had, 100 milligrams. Okay, well, 2 hours later you have 1/3 of that amount, which means you're going to go 100, times 1/3. Okay, and you get 33.333. So your first hour, you have 100 milligrams. Your second hour, or I'm sorry, 2 hours later, right? So your second, so it's going every 2 hours. So 2 hours later, all right, you were at 100 minus 30. So you're at 66.66, right, milligrams of caffeine. Right? And then that following 2 hours, so now we're at 4 hours later, okay, or your third term in the sequence, because this is going every 2 hours. So every 2 hours, so that 4th hour here, we're going 66.666, and we're going to multiply that number by 1/3 again. And now our third term in the sequence is 44.437, ... Okay? So on and so forth. So again, what's happening here is each term is being multiplied by 1/3. Okay? The only one that stays consistent is the third option. All right? So this is, again, an exponential function. Right, is decreasing by 1/3 of its amount each time. So this one is correct because it's constant. 2 liters of water evaporate from the pool each day. So let's say you have, I don't know how many liters a pool has. All right, so 400 liters. All right, so day 1, all right, you lose 2 liters. So now you're at 380. Day 2, you're at, or not 380, it's only 2. 398, then you're at 396, then you're at 394, then you're at 392, okay? It's decreasing by 2 at a constant rate. So 3 is your correct answer. Okay? Because it's decreasing, decreases by a constant rate. Okay? So that's number 6. Number 7. Okay, number 7 is kind of fun. All right? I would say this is, well, number 6 and number 7 are probably are more challenging questions for this section. Okay? And so let's just read number 7 here. So it says Maria orders T-shirts for her volleyball camp. Adult-sized T-shirts cost $6.25 each, and youth-sized T-shirts cost $4.50 each. Maria has $550 to purchase both adult-sized and youth-sized T-shirts. If she purchases 45 youth-sized T-shirts, jeez, it's a tongue twister. If she purchases 45 youth-sized T-shirts, try saying that 5 times fast. Purchase 45 youth-sized T-shirts, 45 youth-sized T-shirts. Anyway, if she purchases 45 youth-sized T-shirts, determine algebraically the maximum number of adult-sized T-shirts she can purchase. Okay. Whew. It's a mouthful. I need a drink of water. Okay. So it says, Maria orders T-shirts for her volleyball camp. All right, the adult size costs this much. And the youth size costs this much. Okay. Maria has this much money to spend on both size T-shirts. And they want to know, if she purchases 45 of these youth size T-shirts, how much money does that leave her in order to spend on the adult size? Okay? So it's very similar to a how many, how much problem. Okay? Now in this case, all right, our how much is, all right, so let's just say X is equal to the adult size and Y is equal to the youth sized. Okay? And so, adult sized T-shirts cost $6.25 each, plus the youth sized T-shirts cost $4.50 each. And this is her budget. It's $450 total. That is the maximum amount she can spend. Okay. Now, in this case, right, our how many, okay, so this is kind of like our how much, right, our how many is already kind of given to us. In this case, she purchases 45 youth-sized T-shirts. So really, it's a substitution problem, but I don't think it gets too carried away here, right? So we just take 45 and we put it anywhere we see a y. So it's going to be 6.25x plus 450 times 45 is equal to 550. And then we just solve. Okay, so first we need to multiply 45 times $4.50. So we get 6.25x plus 202.5 is equal to 550. All right, subtract 202.5 from both sides. We get 6.25x is equal to 347.5. Divide all that by 625. We get x by itself. And 347.5 divided by 6.25. And you get 55.6. Okay. And here's the real question here. All right? Can we buy 0.6 of a T-shirt? All right, does that make sense? All right, no. So the maximum amount of T-shirts that we can buy, youth or adult sized, okay, because remember they gave us the youth size one, right? So the maximum amount of adult sized T-shirts we can buy, we're going to have to round down because we didn't buy 56, we can only buy 55.6. So the maximum amount is 55. Adult sized. Okay? Let me put that in red here so you guys can pick that out. It's 55 adult sized. Okay? That's the answer to number 7. Number 8. Okay. Read this one carefully, all right? So it says, a plumber has a set fee for a house call and charges by the hour for repairs. The total cost of her services can be modeled by this function right here. C of t is equal to 125 times t plus 95. So we will need to determine which of these statements about the functions are true. All right. So let's kind of break down this function right here for a second. Let me write it off to the side here. C of t is equal to 125 t plus 95. All right. I'm writing it off to the side here, so I'm able to kind of demonstrate more of what this really, what it is we're really looking at. All right. Now, C of t, right, is just a fancy way of saying y. Right. This is our output. Okay. That's what that represents. Right. T is our input, right? Right? And so in which case it says, what is our t function? Right, so the total cost of her services can be modeled by this function right here, right? Well, we'll get there yet. Hold on a second. I'm jumping ahead here. Also, let me give myself some space here. All right, there we go. Okay, output, input, good. Okay, so our input is t, right? It's 125. Well, that's our slope, right? And then 95 is our y-intercept. Right, so don't forget, this is just very similar. So I'll write it down here. Y equals mx plus b. Okay. So where x is our input, y is our output. Okay. Our slope in this case is 125, and our y-intercept is 95. Now let's think about what all those things mean. So 95 is our starting point, right? Okay, this is where x is equal to 0. So when nothing has happened, we are at 95 when we graph this function, which means, all right, that our house call fee, right, before he even does any time, all right, before he spends any time working on your plumbing, okay, actually it's a her, right? Okay. All right, for her services, all right, is 95 bucks. So before we even start getting work done on our toilets, all right, we're getting charged 95 bucks. So that one is true. All right, so we're just going to put a T right next to that one, all right, for true. Now, the plumber charges $1.25 per hour, okay? This keyword here, per hour, all right? Usually when we've used per, all right, it's in the sense we're talking of slope, right? We're referring to the slope. All right, we've already discussed, all right, just by breaking down this function, our slope is 125, all right? Which means our plumber charges, okay, for every hour extra, 125 bucks. All right, so this one is also true. And then the third one says, okay, the number of hours the job takes is represented by T. So let's think about what T represents here. Okay, we got 95, which is our starting point. Okay, what we're being charged right off the bat. And then for every hour, okay, for repairs, you're getting charged 125 extra bucks. So the number of hours the job takes is represented by T. Yes, T is the input, in which case our input is the hours for repair, right? That's how repair works, okay? You guys have ever taken something to get fixed, all right? They charge you a flat fee, and then the amount of time it takes them to fix that particular part or object, okay, is what you get charged for a total bill. All right, so in this case, you're starting out with 95. You're getting charged $125 per hour, And the number of hours a job takes is represented by this input t. Okay? So all of these are true, which means, all right, which statements about this function are true? 1, 2, and 3. So it's kind of a trick question. Very rarely do we ever see all of the answers correct. So in this case, we did. All right, so that's the answer to number 8. Number 9. Oh boy, number 9 is going to take us a little bit. Okay, hopefully I don't run out of battery here. Holy cow, I'm pushing it to the limit here, folks. We're at 16%. I hope we make it. All right. So it says, how many of these equations listed below represent the line passing through the points 2, 3 and 4, -7? All right. There's a couple ways you could go about this. What you could do is you could take each one of these points and substitute it in for your x and y values here for each equation and see which ones come out to be true. All right. Or you could plug all these into your calculator, okay, and see whether or not these 2 points fall into your table of values. All right, so we're going to use let me rewrite this here. Hold on a second. Okay, we're going to use our calculator, right, in order to check whether or not these 2 points fall into your table of values. Okay? That's what we're going to do. All right, so let me shrink this down here. All right. Use your calculator to check and see whether or not these 2 points fall in your table of values. Okay? So in order to do that, we got to set y equal to it. We got to set y by itself. Okay? So in this one here, we're going to have 5x plus y is equal to 13. We subtract 5x. We get y is equal to -5x plus 13. Okay, so when you take this into your y equals. That does not look clear. Let me rewrite that again. Plug into y equals. Okay? So you go to your y equals -5x plus 13. Go to your table of values. I don't know why. Holy crap. Mine was way up in the 40s. All right. So here we go. So we're going to look at 4, -7. 4, -7 is good. All right. How about 2, 3? 2, 3 is good. Okay. So this one checks out for both values. Let's take a look at this one. So we're going to have y plus 7 is equal to -5 x minus 4. Okay, so we're going to distribute at -5, so we're going to get y plus 7 is equal to -5x plus 20. Subtract 7, and we get y is equal to a -5x plus 13. Now you're thinking, okay, let's plug this into your calculator. Uno momento, por favor. Didn't we just do that up here? What do we have here? We got the same exact equation. So we know that this one's good. Oh, and behold, what do we have down below? -5x plus 13. That's exactly what we have in the other two. They're just not simplified. So those three work. now we just have to make sure that this one still works. Okay, so y minus 7 is equal to, and I'm going to distribute that 5. So we're going to have 5x minus 20 plus 7. I get y is equal to 5x minus 13. Okay, so let's plug that one into our calculator. So we're going to go 5x minus 13. And you plug that into your table of values. As you can see, when we plug this one in, all right, when we plug y equals 5x minus 3 into our calculator, we see we do get 2, but at 2 we don't get a 3, we get a negative 3. And when x is equal to 4, we get a positive 7 instead of a negative 7. So this one is out. So therefore, how many of these equations listed below represent the line passing through the points 2, 3 and 4, negative 7? It's only 3 of them. Okay. Last but not least. All right, let me switch it to color. I'm going to go blue. I like the way the blue looks. Blue looks sharp. Okay, so what is the solution to the equation here? 3 over 5 times x plus 4, or x plus 4/3. I'm sorry, I was fidgeting or something. Yeah, so let me read this right here again. All right, so what is the solution to the equation 3 over 5 times x plus 4/3 in parentheses equal to 1.04? All right, real nasty looking solution here. We're getting all decimal numbers here. All right, so MathFrac is your friend here. So I'm going to multiply that in there. All right, so when I do, I'm going to get 3/5 x plus. Now remember, when we multiply with fractions, you multiply straight across. So this one's going to be 12 over 15 is equal to 1.04. That's what you should get. Now, because this is in decimal form, all right, we don't really have to worry about MathFrac in this one, I guess. All right, so I lied. Don't worry about MathFrac, because if you look, all of these numbers are in decimal form. So don't even worry about it. Okay, so we're going to then subtract 12 over 15 minus 12 over 15 from both sides. So you get 3/5 x is equal to, so 1.04 minus, now make sure when you go to subtract this, you put these in parentheses. Okay, it's very important that those go in parentheses when you go to use your calculator here. Okay, if you don't, your calculator will screw that up. So make sure those are in parentheses. So we go 1.04 minus 12 divided by 15 in parentheses is 0.24. Okay? Now, our last part, shrink that down here, okay, is to get x by itself, we need to multiply both sides by its multiplicative reciprocal. Okay? What that means, oops, let me give myself some space here. Okay? What that means is when you multiply both sides by 3, oops, did it wrong there, didn't I? Yayo, 5 over 3. All right, when you multiply both sides by 5 over 3, what happens on the left? These two things cancel. You're left with x, and then 0.24 times 5 over 3. Make sure, if you're using your calculator, make sure you put that in parentheses, okay? Please. All right, otherwise you're going to get different answers, all right? So 0.24 times 5/3 in parentheses is equal to 0.4. And do we see that answer over there? Oh, we sure do. All right, good stuff. So there is our answer to number 10. Okay, so this is day 1 and day 2 of the linear function section. I'll be sending everybody this email. Okay, sorry if you guys were copying that in there. Make sure you pause this. Okay, and anytime you need to stop, just pause the video. Okay, so that's day 1 and day 2. Okay, so you guys should be working on day 3 today. I'll be sending those answer keys out probably by Thursday. All right, or at least Friday. You know, we're expecting at least Wednesday by tomorrow, and Thursday, Friday by over the weekend. Okay, so just keep working, you guys. All right, hope everything's okay. And please, if for some reason this isn't beneficial, or like Mr. K, these videos, they stink, I can't learn from them. All right, reach out. We can try to come up with some other better solution in order so you guys can better handle this material, because this is all important. These are all Regents questions. Okay, and so it's important that you guys are not losing any progress. Okay, I keep saying progress because you guys have worked so